Thanks a lot. My name is Danny Langley. I'm a senior solution architect on the Qlik federal team. And for the next several minutes, I'm going to be demonstrating how geoanalytics can be used for several different use cases. Now, geoanalytics is an extremely powerful part of our platform because it combines the power of Qlik's associative engine with advanced geospatial functionality. Now, when I demonstrate geoanalytics, a lot of times the initial thought that many people have is, isn't geoanalytics just, um, you know, basically mapping layers that you add to a dashboard? Why is it so special? So to answer that question, I want to begin this demonstration with a really simple sales use case just to drive home the point of what geoanalytics is all about. So let's go ahead and pretend you are a store sales manager. You've just opened up a new store, Store B. You're really excited about it, but the sales really haven't been where they should be with Store B. Now, as you can see in this table, you've got data on where the stores are located. You can have data on the customers and even overall sales data. Now, can you guys see the issue that's going on here? Can you see the problem? I'm guessing probably not, unless you're like a Rain Man type of person. You probably can't see the issue that's going on here. So let me go ahead and go over to the dashboard. Now this is more of a traditional dashboard that you would set up with this sales data. I can see, what the total sales are, the number of orders, and then of course I have some other visualizations including these maps at the bottom where I can see sales by customer and sales by the stores. And of course this dashboard is fully interactive. I can make selections on it. I can select store B and I can see what's going on here. Now, unless I drill through this and really kind of investigate the data closely, I may not still be able to find what the issue is exactly. So let me move on to this last view within this app that's using geoanalytics. So right away, if you're looking at this map, you can probably point out the issue. You've got customers that are going to store A that live very close to store B. Now what's nice is that I can even add in an additional area layer that shows 20-minute drive times around each one of the stores. Now it becomes even more evident that customer 3 is, for whatever reason, still going to store A instead of store B, which is probably the more logical location for them. So now that we've identified this issue, we can take appropriate action by doing things like increasing marketing for store B to attract customers that live in the general vicinity of store B. Now think about this in use case terms. Maybe you are improving a military installation. You could use functionality like this to really optimize the location of facilities that you are potentially going to install in certain areas. Okay, for this next use case, this is based on an app that one of my colleagues put together based on Hurricane Irma. Um, just as a little bit of background, so Hurricane Irma was the most powerful Atlantic hurricane in recorded history. It was a Category 5 storm when it made landfall in Bermuda back in September of 2017. So it got a lot of press when it was occurring, and my colleague actually put this together basically right around the weekend of when this was taking place. And so the first view that you're looking at here, it's not too exciting at the moment. You'll notice there is basically a precipitation layer. Looks a lot like the Doppler radar that you'll see on the news. This is based on a mapping service layer that we added to this particular map. Now this is actual live feed from NOAA. So the point here is the fact that you can actually add in a live mapping service for any of the apps you're developing using geoanalytics. Now, when this hurricane was taking place, what's interesting is that there was an actual additional layer on this map that showed the path of the hurricane in real time. So it gave you some interesting data points about the hurricane, and you could see the path of the hurricane moving basically across the southeast of the U.S. Using that particular mapping layer from NOAA. I'm going to go ahead and move on to the next sheet. So for this next view, we can see wind speed probability bands. Each one of these colored bands represents where wind speeds were equal to, or the probability of when wind speeds were equal to or exceeded 39 miles per hour or 34 knots. Now, these are based on shape files that the National Hurricane Center released that we loaded into this app. Now, I wanted to point that out because that's a question that we often get is, hey, Danny, a lot of times we're working in Esri with shape files. Is that a type of data that you can load into Qlik? And the answer is absolutely yes. Now, for this particular visualization, we're probably going to want to hone in on the bands where the probability is, let's say, 70% or greater, because that represents where the hurricane was the most intense. So I'm going to go ahead and select those particular wind classes. And now I'm going to go ahead and move on to my next view. Now, as we would expect within any Qlik Sense app, the filters that we applied on the last view have traveled with us. So we're still really honed in on the most impactful part of Hurricane Irma. What's interesting is that the kind of three most populated areas that you can see here that are represented within these bands is Southern Florida, the Virgin Islands, and Puerto Rico, all of which had states of emergency declared by President Trump when Hurricane Irma was occurring. Now, you can see that from a population perspective, the greatest number of people were going to be affected within the 70 to 80% band, right? Which was probably the least intense of these three bands. But we might be most interested in looking at is the over 90% probability band, because this represents where Hurricane Irma would have, in theory, been the most intense. So when we do that, you can see that now we've kind of zoomed into Puerto Rico. And you can see that San Juan in particular, right around here is where the most people are going to be affected. So if we wanted to drill in even further, we grab our lasso and we could go ahead and lasso those particular areas. Now, the one question that maybe some of you all had as I was showing these bands and the populated or the zip codes of population was, hey, how did you correlate these zip codes to those particular bands within those shape files? This was using a GeoAnalytics function called within that allows you to make correlations between data sets that aren't necessarily naturally correlated to one another. So that can be a very, very powerful thing within a Qlik Sense app that allows you to do things like I'm doing right now to hone in on specific zip codes within this particular band. All right, I'm going to go ahead and move on to my last sheet within this app. From this view, we're getting some more specific information about hospitals that would be affected by Hurricane Irma in those particular zip codes that I just lassoed. What's nice is that each one of the hospitals is represented by a particular triangle here, and the size or the number of beds associated with each hospital is represented by the size of the triangle here. So, from a mobilization standpoint, when you're trying to figure out how you should send out resources to help out these particular hospitals, you can see that this particular hospital here, Metro Pavia Health System, and maybe the hospitals in this particular area would be where you want to mobilize resources first, potentially. Just in general, it's going to allow you to mobilize resources in a more effective and efficient manner. Just kind of a side note here, we're using the triangle, which I believe is the universal symbol for hospitals. Um, and you can do that within the native Qlik Sense platform. But if you have, custom icons or custom images that you wanted to use for each one of these points, that's something that you would be able to do within GeoAnalytics as well. From use cases perspective, I would like to think that you can see some direct parallels for how you might want to use some of this functionality when a natural disaster is occurring and you're trying to figure out, okay, what infrastructure is going to be the most affected, and how can we mobilize resources around that infrastructure in a way that's going to be smart and timely. This app was actually used to show the Chief of Staff of the Army, General Milley, how many soldiers and dependents would be affected by the storm. So this is a FEMA app that we created as part of a proof of concept exercise. And this app provides several different geospatial views to look at infrastructure that could be impacted by a natural disaster. So a user can filter on specific disaster types or even specific disasters that have occurred and just see historically how and where they've had the greatest impact. The app brings in several different data sets from FEMA, EPA, and CMS. So it's a really great example of utilizing Qlik's power to bring together lots of different data sets to get a holistic view of overall impact from many different angles. So what are we looking at right now exactly? Well, this is showing you all the different manufacturing facilities that are located across the U.S. So you can imagine there are quite a lot of facilities. You can see there's over 21,000 facilities. So when you're working with a volume of geospatial points this large, a lot of times it makes sense to aggregate those points in some sort of visual way. Now in this case, we used what's called a binning geoanalytics function that created these hexagons so that you can clearly see across the US, okay, where are the greatest density of facilities located? You can see up in the Northeast, we have a swath of lots of facilities. And you can see that in the Texas area, we have a high concentration of facilities as well. You'll notice as you hover over a specific hexagon here, it's going to show you the number of facilities located in that particular geographic area. Additionally, you can see that if you wanted to, you could also filter by specific industry sectors as well. So at the moment, this particular view isn't super helpful to us, but let's just pretend that maybe I'm an analyst for a chemical company, and I wanted to know, during Hurricane Katrina, which locations could have been most affected based on the number of chemical facilities. So what I would do is I'd come up here to my smart search, and I'm going to type in exactly what I'm interested in. So I'm going to type in Hurricane Katrina, and I'm going to type in chemical and chemicals, right? Because now if I look down here in my smart search, it was smart enough to understand that, hey, I'm interested in Hurricane Katrina, and then these two industry sectors, chemical wholesalers and chemicals. So I'll go ahead and select that now. And now we can see that, as we would expect, kind of the Louisiana, Alabama area is going to be kind of the most affected, or was the most affected by Hurricane Katrina. I can see that there were 127 facilities that were in the chemical wholesalers or chemicals industry sector. And then we can even see that, okay, this looks like this is the specific geographic area where there would be the greatest impact for this particular industry sector. So I'm going to go ahead and zoom into this bin. And when we do that now, we can see the specific facilities and see the facility names that would be affected here. We can see at this point that there are 22 facilities that were impacted. And this is to say, for whatever reason, we want to know, okay, well, what's the number of facilities that are not chemical related in this particular area? So any of you guys who have been using Qlik for any extent of time, you know that these light gray values are showing you kind of the alternative selection. So they're not selected right now. But what I could do is I could come up here and I could say, you know what, I want to look at everything else except for my selected value. So I'm going to say select alternative. And just like that, now we can see everything that's non-chemical related. We can see there are about 24 facilities. So about half of these facilities are in the chemical wholesaler or chemicals industry sector. I'm going to go back to where it just was. So as a side note, this analysis is largely based around historical data that was collected on natural disasters. But we actually have a partner that used concepts from this POC app as a springboard to create a new app that actually uses statistical modeling data to predict infrastructure impact for natural disasters that are about to happen. So in other words, in September or October during hurricane season, as a hurricane is spotted out in the Caribbean and is headed towards, let's say, Florida, their app can actually predict with a high level of accuracy which counties and related infrastructure would be impacted. So I just think that's a really neat example of combining the power of Qlik's GeoAnalytics with advanced analytics as well. Okay, so maybe it's the end of the day, and I want to save where I'm at in this analysis. So I'm going to come up here to my bookmarks, create a new bookmark, and I'll just call this Katrina Chemical Analysis. And let's pretend it's the next day. I come into my app, I go to my bookmarks, and I go to Katrina Chemical Analysis. And we're right back to where we were before. And maybe I shared this bookmark with another analyst, and they are concerned about this particular area, or they really want to analyze this particular area, but maybe they're not as concerned about the chemical sector, right? What they might do is they might use my bookmark, they'll come to this area, then they're going to move over to this next sheet in the app, which is showing you electrical utilities impact. Now, of course, my filters have come along with me, so I know that I'm still looking at this specific geographic area. If I hover over specific plants, I'm getting the name of the plant, and even I'm getting an associated criticality rating. Just as an FYI, this criticality rating is something that I completely made up for this proof of concept, but just so you know, you could do something like that as well. And then finally, this will be similar to the hurricane app that we showed before, but maybe if I wanted to see, what would be the hospital impact, I could move on to this lifeline impact sheet. Now this is showing you all the different hospitals that are in this particular area as well. Now, just to recap, hopefully you can see some obvious applications in your organization in terms of, identifying areas of infrastructure impact, especially when you're dealing with a large number of geo points. You can use geoanalytic functions like the binning function to easily see high density areas of geo points. Additionally, hopefully you notice all the ways you can use just the native Qlik functionality like the smart search, alternative selections, and bookmarks to analyze in some smarter ways. So this is an application that we built for the Pennsylvania Department of Transportation. Specifically, they were analyzing the Pennsylvania Turnpike to see maintenance locations and what the drive times would be to get to accidents, snow removals, etc. along the turnpike. Now this app shows maintenance locations, average road speed, accidents, and drive times from the maintenance locations to the surrounding areas. Now what you'll notice in this map is that there are a lot of different layers that were used. Now this is a great example of using multiple layers in a smart way so that you're getting continual feedback and drawing out insights based on the specific area that you're focusing on. You'll notice as I kind of hover over these different maintenance locations, you can see the names of those maintenance locations. The heat map layer showing you the concentration of accidents. So you can see it around the Philadelphia area, there's a lot more accidents as you would expect. You hover over some of the line segments, this is giving you the average speed along different parts of the Pennsylvania Turnpike. And as you zoom in all the way down here, you'll notice at some point you're going to get to see all the different specific accidents that they pulled data on, they brought into this particular app. So you can configure when layers actually become visible based on how far you've zoomed into a map. You can see as you hover over particular accidents, you can actually see the accident ID associated with those particular accidents. Now if I zoom back out, you'll notice these blue shaded regions, and maybe you're wondering, okay, what in the world are those? Let's pretend an accident occurs out here in Doylestown. The Department of Transportation actually used these blue shaded regions to determine how long it would take for them to drive to respond to accidents. The dark blue area represents a 20-minute drive time, while the light blue represents a 40-minute drive time. And this is all calculated on the back end using Qlik's GeoAnalytic drive time function. So now we're still in the same Pennsylvania Turnpike app, but as you can see, we've loaded about 500,000 Waze reports. Now, I'm sure that most, if not all of you listening to this webinar are probably familiar with Waze. If you're not, it's a live navigation and traffic reporting app that uses incident reports that users can submit while they're driving. So for instance, if maybe I can see that in 1.5 miles on my app, there might be an accident, or maybe there's a cop waiting to pull me over for speeding. It's actually a pretty cool app if you haven't used it before. But this is just another great example of Qlik's ability to combine different data sources, and now we're going to use Qlik's geoanalytic capabilities to get smarter on some of the incidents that users are reporting on in the Waze app. Now, let's say you can see that we have all the different incidents that are showing up on this map, again, using the heat map here. But maybe we're particularly interested in looking at, let's say, maybe a fog-related incident. So I'm going to come up here to my smart search or to my filter here, and here we go. Find fog, select it, And now what's interesting is that the majority of the incidents are actually not in Philadelphia or around Pittsburgh, like you would, or like what you normally see when you're just looking at accidents in general. For fog-related incidents, they are located in this particular area here, or the majority, or many of them are located here. So I'm going to zoom in, and now you can see that once you zoom in, we're actually combining uh, the binning function, or have a binning layer here. So now we can see where the greatest number of incidents are occurring. In this case, you can see that there are a lot of incidents right here in this particular area. So I'm going to go ahead and select this. And now we can see, okay, all the different specific incidents that are fog related in this really specific section of the Pennsylvania Turnpike. Now, what's interesting as well is that obviously our green, white, and gray is in effect over here on the side filter. What's interesting is that none of the major accidents or minor accidents were actually reported in this particular geographic region. Now, that might actually be the case, or maybe that's something that we want to investigate and figure out why no accidents were actually reported in this particular area. Again, to kind of using the Qlik green, white, and gray color scheme to further investigate that. So from USACE's perspective, if you are tracking incidents or accidents that might be occurring around, let's say, maybe a construction zones, and you want to get a better idea of the types of incidents that are occurring from a geospatial perspective, hopefully, this provides a good example of how you could do something like that, which ultimately would help with response times and any kind of preventive measures that you might be able to put in place. Okay, well, thanks a lot, and hopefully everyone learned a little bit more about Qlik's GeoAnalytic capabilities, and this has spurred on some new ideas for how you might be able to use these capabilities with your own data sets.